In this video, I'm going to look at the ratio test. Now, the ratio test can be used to determine whether a general series is absolutely convergent and hence convergent. All right. So if it's absolutely convergent, then you can say by ratio test it's convergent. So here are some conditions that you have to know. So if the limit of the absolute value of s sub n plus 1 over s sub n is less than 1 as n approaches infinity, then we'll say that the series is absolutely convergent. And if that limit is greater than 1, then we'll say the series is divergent. If that limit is equals to 1, we'll say, well, it's inconclusive, which means you need to use another test to check what's going on. Now, this test, it works well for series that involves factorials and constants raised to nth power. Okay, so example 1. You have been asked to test whether this sequence, to test the series formed by this sequence, if the series formed by this sequence converges absolutely. So what you are going to do is we are going to start working out. So s sub n is given by that, and then s sub n plus 1 will be given by negative 1 to power n plus 1 n plus 1 cubed over 3 to power n plus 1. Okay, so what I need to do is to find the limit as n approaches infinity of absolute value of s sub n plus 1 over s sub n. So what that means is that will be the limit as n approaches infinity. Let me write it below here. So limit as n approaches infinity of absolute value. Now, s sub n plus 1, we have it on the other side, which is negative 1 to power n plus 1 multiplied by n plus 1 cubed over 3 to power n plus 1. Now, this divided by s sub n, which is given by negative 1 to power n, n cubed over 3 to power n. Now, before I carry on, there's something that I want to mention. And this is what I'll be doing as I move along to other examples. Now, one thing is, if you notice this guy, all right, powers negative 1 to power n plus 1, negative 1 to power n, because you're taking the absolute value of what's inside here, all right? Absolute value of negative 1 to power any power is just 1. So you can just ignore that. You don't even have to write it, all right? Because you're taking absolute value of these guys. So we can rewrite this expression as ignoring the negative 1 powers. So I'll have limit as n approaches infinity of absolute value. Now here I'll have n plus 1 to power 3 over 3 to power n plus 1. Now I'm going to change this to multiply and just take the reciprocal of that, 3 to power n over n cubed. Now you can simplify this guy, right? You can simplify this guy to end up with the limit as n approaches infinity of this will give us a third, because remember 3 to power n, all right, divide by 3 to power n plus 1, that will be 3 to power n minus n plus 1, which gives us 3 to power negative 1, which is a third. Okay, just keep that in mind. Indices. So what you're going to have here is a third, and then we'll have n plus 1 cubed over n cubed. All right. Now we can write this as limit as n approaches infinity of, actually let me factor out a third. Of absolute value of n plus 1 cubed over n cubed. And well, the numerator here is just a polynomial. Of the highest degree of this polynomial is n cubed. So by LHS, right, by LHR, L'Hopital's rule, this will be equal to a third multiplied by 1. All right. So, right. Let me write it here by LHR. All right. So our limit is a third. And if we go back to what we mentioned, now a third is less than 1, which means that our series is absolutely convergent. So we can go back and write our final conclusion. We can say, hence, all right, by ratio test. So that's how you work out a question like that, applying ratio test. Next question, classify this series as absolutely convergent, conditionally convergent, or divergent. So we are going to use ratio test again. Now here I'm going to ignore negative 1 to power n plus 1. You know why? Because you're going to take absolute value of s sub n plus 1 over s sub n. So I'll just consider this bit, right? No need of negatives. So because it's negative to power 1. If I had negative 3 to power n plus 1, then I won't do that. Okay? This is because it's negative 1 to power n plus 1. So I'll go ahead and say, well, my s sub n is equal to 2 to power n over n squared. And s sub n plus 1 is equals to 2 to power n plus 1 over n plus 1 squared. And then we can carry on. So the limit as n approaches infinity of 2 to power n plus 1 over n plus 1 squared divided by 2 to power n over n squared, which will be equal to limit as n approaches infinity 2 to power n plus 1 over n plus 1 squared multiplied by n squared of 2 to power n. And this simplifies this to, I'll take a shortcut here. This will be the limit of 2 multiplied by n squared over n plus 1 squared, which is 2, the limit as n approaches infinity of n squared of n plus 1 squared and which is equals to 2 by LHR, L'Hopital's rule, all right? No need of putting that out. So we can, write our conclusion. Hence, this series diverges because this is greater than 1. So this diverges, and this is by ratio test. Okay. Okay, let's carry on to the next question. Example 3, use the ratio test to establish whether or not the following series converge. Absolutely. Now here, like I said previously, here I have -3. If I had -1, I would have ignored that bit. But I have -3 to the power k, there's no way I can ignore that. So what I'm going to do is my s sub k, that will be -3 to power k, k to power 10 over 10 to power k. And s sub k plus 1 will be -3 to power k plus 1 k plus 1 to power 10 over 10 to power k plus 1. All right, so we have this bit. Now what we need to do is put these guys in an expression, find their limits, and then we can decide what's going on. So the limit as k approaches infinity, here we have k, so have to change that, careful, of absolute value of s sub k plus 1 divided by s sub k, which will be -3 to power k plus 1, k plus 1 to power 10 over 10 to power k plus 1 divided by -3 to power k, k to power 10 over 10 to power k. So that will be the limit as k approaches infinity of the absolute value -3 to power k plus 1, k plus 1 to power 10 over 10 to power k plus 1 multiplied by 10 to power k over -3 to power k, k to power 10, which will be equal to the limit as k approaches infinity of so I want to reorganize things here. Powers of k, -3k, k to power 10 and k plus 1 to power 10. I want to organize those information so that I can simplify them. It's just making it easy for you to simplify. So -3 to power k plus 1. Just rearrange things, changing the expression, power k multiplied by, then here can have k plus 1 to power 10 over k to power 10 multiplied by 10 to power k over 10 to power k plus 1. So nothing has changed. I've just rearranged things, all right? Because it makes it easier for me to simplify. So what I'll end up with is -3 multiplied by k plus 1 to power 10 over k to power 10 multiplied by 1 over 10, which will be the limit as k approaches infinity of 3 over 10. Now, I can take 3 over 10 outside. So 3 over 10, because absolute value of negative 3 is just 3 over 10. Limit as k approaches infinity of k plus 1 to power 10 over k to power 10. And, k plus 1 to power 10 is just a polynomial which is highest degree is 10 over k. So by LHR, L'Hopital's, this will be equal to 1. So this will be equal to 3 over 10 by LHR. All right. And this series converges absolutely by ratio test.